Good morning.
Good morning, sir.
Very good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning.
Yeah, very good morning. Welcome. So I hope two sessions are over, right? Two courses yesterday. Today morning one over, third one. It is the fourth. So how is the experience of restarting?
It's nice, sir.
So
It's
yesterday 4 hours,
nice,
today.
and whenever it is matrix, uh, some things are going above.
Math is math. But the math is
Yeah,
required here is very
it
simple.
seems like we need to yeah, invest more time in that.
Yeah.
We have to refresh all the
हॅलो
logics
बोल ना.
and thing.
अरे लेक्चर अटेंड करतोय.
Good. Good.
Lot of
लेक्चर
max, full max.
No, actually, so kids are at home with the holidays. Managing them is a difficult job for many. Okay, thank you. I think we can start with the course introduction. Yeah, Sushant, Suresh, any? Sushant.
Hello, sir. It was by mistake. I was about to
Okay,
look
okay.
for the chat. Sorry, sorry for
Okay.
that.
Oh, no issue, no issue. Any doubt that you had? I think again, welcome. So, good morning, good afternoon, and welcome to this session. So, I think this course, if is another name, maybe you can coin it for this is a deep learning. Suppose if anybody asks, like, have you done deep learning? Yes, this is nothing but deep learning. So, what is that we are going to have as a part of this course? I think same apply here. Anyhow, handout will be there. So, one important thing is already you are having machine learning in parallel, right?
Yes.
Machine learning is going in parallel, and this is also a parallel deep neural network or deep learning also you can call as. So it's very important for every one of us to be very comfortable, confident with these two courses, which are essential. MTech AML means you have to be very convergent with ML, DL, and all those, right? Here, we'll try to see why we need to go for deep learning. So what are the applications? And after that, we'll try to have some basics related to the neural network architecture. Uh, so how this same can be used for something called as a regression, something called as a prediction, and one more concept that is feed forward back propagation. So these are the things what we discuss.
Sir, your voice is breaking. Is it same for everyone?
So sixth
Yeah,
module
yeah.
on
It's
Yeah,
seventh
for me as
algorithm
well.
which we use. It should not be. Yeah.
And now that's now
So
that's fine.
then we'll have the architectures exclusively for different requirements. One is CNN, other one is RNN.
So your network is not stable.
Should not be. No, it is an office. Maybe too heavy.
Your voice
It is fine
breaking,
now,
sir.
sir. Earlier it was breaking. It is fine now.
Today there should not be like that. It should not be. Okay. So then we'll have the discussions related to exclusive algorithms or architecture, CNN, convolutional neural networks, then recurrent neural networks, then LSTM. Some of you might have heard these names already. Right? Then other one is one important concept, attention mechanism, and most importantly, the transformer architecture. So I think we are already familiar in terms of using these kinds of things, chat GPT or something like this, right? The architecture behind chat GPT is transformer architecture.
Oh,
So transformer architecture is the base for which one research paper by Google Research Group is the triggering point, actually, attention mechanism related paper, research paper. Attention, all you need is one of the popular papers, which is a game changer, we can say, which triggered the transformer architecture. Then you know, right? Many things happened in the front, chat GPT, etc., etc. Then at the end, we'll go for some of the concepts we
Sir, you're
Sir,
breaking
your voice is
completely.
breaking.
Yeah.
in between here. That optimization.
Sir, we are unable
So
to
finally,
understand.
what is the
Sir,
what?
we lost you for a couple of seconds due to poor
I'll
network.
try to just give me a minute. Give me a minute. Right. So finally, at the end of this, what is the outcome of this course is? So the differentiation between what makes the difference between ML and DL. Right. So it should be very clear in terms of whether I need to go for ML approach or ML architectures, ML algos, or deep learning or DL algos is one take we should have at the end of this course, right? Because you are doing ML, you are doing DL. It should be very clear whether I need to go for ML architecture or I need to go for DL architecture is one important aspect, because this is a requirement for you when you work with real-time scenarios. You will have a customer related requirement. You had a problem statement. Then whether I should go with ML or DL approach is one important thing you need to have. Second one, the architectures. That is CNN, RNN, LSTM, and also the transformer architecture. Think so. This is the expected output from this course. And remaining things, what we discuss is a part of some of these architectures, right? Particularly when we work with images, CNN is what is used. Why we have to use, we'll go for the discussion whenever we start the discussion. Similarly, when we work with sequential data, then we'll look towards RNN LSTM architecture. Then more way further, then we'll see why we need transformers, where we need transformers, and all those discussions. Okay? Yeah. This is all about the complete structure of the course. Okay. And book, I think this is the book which we are following as it is. I think they can, it will be shared. You can download and have the copy. Okay. And this is a very popular textbook. Very popular. Those who want to try, you can try this textbook. Okay. And evaluation components. So here almost similar. You will have the two quizzes, quiz 1 and quiz 2, and we have assignments. So 20 marks. And the rest of the things as mentioned. So here So there is no confusion. Assignments both are hands-on. Right? So you have to, with the problem statements will be shared. You have to work and submit the workings. Right? And here generally keeping the constraints, we prefer to go with, we insist to go with group assignments. I hope I already heard this from a previous morning session, right? Or some other courses. So group assignment is what we insist for. The reason here is collaborative learning, and also uh, time is a constraint, right? So 2 to 3 people sit together and work on a problem statement and submit as a group assignment. Okay. So how
Sir,
this?
sorry to interrupt, but a
uh,
quick question here. So the grouping of this assignment, right? So how will the groups be formed? So will you be
One is
suggesting?
we'll give an option for you guys. You can form the groups if you know the people, connect with the people, or otherwise we'll do it randomly.
Okay, sir, thank you.
So do we need to declare those groups previous to the assignment somewhere, or
We'll communicate it in the LMS, the group formation, which I have to do it. But my suggestion is better to identify the people who can gel with you and form the groups, right?
yes, sir.
Yeah. And I think someone asked, like once you go, if you go through the handout, you will understand the session wise lecture plan. You know, right? We'll have total 16 sessions, 16 weeks, right? After 8th session or 8th week, you will have mid-semester examinations, right?
Hmm.
You should not ask anyone actually. The syllabus covered as mentioned in the handout till 8th week is meant for mid-semester examinations. The default actually. For the Compre, it is combining together. Maybe from course to course, faculty will give the input saying that how much weightage. So 1 to 8 mid-semester. At the end, we'll have Compre examination, right? Generally, because already this is covered in the mid-semester, then faculty will tell maybe 10% weightage will be given for this. There is no rule as such, but generally faculty will give some hints on it, right, for Compre examination. That is what.
So this compre
Sir,
exam, will it be open book?
In the group, how
Yes,
many people can have a maximum?
we'll
Is there
we'll
a
we'll get we'll send the we'll send the communication. I think max of 3 or 4. I think I remember.
okay?
You will get all the relevant communication in detail. Yeah, that.
Sure.
So mid-semester examination is a typical closed book exam, and Compre exam is a open book exam. Not only for this course, in general, it is the same for all. Okay,
Sir, in
yeah, I
this
think
open book examination, only the recommended books will be allowed, or how it
you
is?
will get, I think, some what we call as
Actually, I have
some
asked this
instructions you will
in
get
like
from the
all sessions, but I didn't get answer yet.
because
watermark assignment something.
because
Watermark
we
PPT.
are not, we should not confuse you. You will get the communication from the concerned department from the university. Because why we are not elaborating that point, I may tell something, you may get something. That's why, to avoid it, the examination team will communicate from time to time regarding that aspect, right?
Actually, if it is like that, if it is only like recommended books are allowed, then we may purchase it right now so that it will be helpful for our like
Yeah, recommended books are
task and
always
all
allowed,
also.
always allowed, and watermark PPTs, etc., etc. Right?
Okay, okay, sir. Okay.
But we
So that's
cannot
why
take the Xerox of the
that's why
PDFs, right?
I don't want to add any information in this aspect, because it should be a conflict sometimes, because the concerned department, I think very soon they will share the information. Just wait for 1 or 2 weeks time, right? Don't worry
Okay, okay,
till
sure.
then. Yeah.
Yeah.
Right.
Sir, in
I
our
am way.
previous
So sorry to interrupt. So in our previous session, it was mentioned that Xerox will not be allowed. But just one question that whether this you refer to two books. One is textbook, another is reference book. So is it like textbook only will be allowed in that case, or reference book will also?
Anything mentioned in the handout is allowed.
Okay. Okay.
Yeah.
Okay.
Yeah. So some of the course logistics, I think already you are familiar by this time. Handout, I think you are yet to get the handout, right? I hope.
It's
And
already
I
uploaded, sir.
uploaded, right? Yeah. Now I think already you heard
or digital, sir?
pen and paper only. Pen and paper in the sense, uh, as an online exam, you will sit before the system. You will have the QP in the system. Then the answer sheet will be given. You have to write and upload it. Or for some course,
Objective, objective or
1 minute,
subjective?
subject to, and some courses depends on the course instructor. No handwritten, where you have to type the answers there only in the box provided, etc. It depends actually. Now, I hope this is you heard this time webinar, right? So I think for every course you will have webinars scheduled during weekdays. I think that schedule will be released in the coming week. In the evenings, late evenings, like 7 to 9:30, I remember, sometime like this. So 4 webinars will be there for this DNN course. The webinars related to hands-on only. You will have some implementations only. My team will present, take the webinars. Right? Okay. So it is more of hands-on related sessions only happens. That too weekdays and the evenings. And I think already you are aware. I think this also will be really getting in the next week. Here, everything is will be known before, because you are all working professionals. You can plan your schedules accordingly. By this week, coming week, you will be getting all the information like a quiz one for DNN course. When and what from when it starts, when it ends. That complete information will be released in the coming week, so that you can plan other activities accordingly to avoid any kind of conflicts. Right? Okay. Yeah. Session slide deck. So it will be uploaded at least by Wednesday or Thursday. By Wednesday or Thursday, this will be the session slide deck will be available in your Takshila account. Once the session is over, the used PPT will be uploaded in the concerned Teams channel. Right. So every faculty will have their own slide deck. They will share it. And one more important thing is you will have the lab. You will be mapped to online lab, virtual lab. What we are having, you can use it. You will have some session to expose or to give details related to usage of lab. So we are having, as a part of WLP, we are having virtual lab as well as remote lab. So this information will have complete details in this session, right? So wait for that time where we'll have demo sheets and all. Okay. And also by this time, I hope are available. Otherwise, after some maybe next week, you can see in every course page you will have sample QPs, sample question papers. Okay. Okay. Yeah, I think these are all already familiar. I already mentioned. Okay. Yeah. And this very important thing, you have to go through this the plagiarism related instructions. Just to have a look is very important, particularly for this course. Right. So you have to take honor the code, right? Okay. So take care of plagiarism during all the submissions way forward. I think change. It is not.
So, sir, if we are forming group for some of the assignments,
Hmm.
then, so for example, in my group we have two, three people, then all our assignments will be equal one, right?
Only one submission will be there for group.
Ah, okay, okay.
1 minute. So you can mail to me. I think I am the IC or the course instructor, the lead instructor for this. Okay, yeah. So already many, I think you might have heard the discussion how to where to like use discussion forum. Discussion forum helps you to connect with other guys and for any queries. Otherwise, anyhow, my team will be checking the discussion forum for any queries to be resolved. Okay. Yeah, Harish Kumar, 30 plus 30 plus 40. Yeah, yeah. Right. Now let us begin, or if you had any general queries to before starting the discussion. I think this is the last course. By this time, you will already familiar with many of the things what we are going to conduct. Right? Now,
Sir,
One question.
yeah, yes.
Uh, so I'm repeating this semester actually because I couldn't complete last time comprehensive exams.
Okay.
Is we need to submit all the assignments and everything?
Yes. It is like
Yeah.
you are a fresh registered student kind of thing. Everything
Okay.
as a fresh student, right? Yeah.
Yeah. Okay. Last year up to midsum I have done, but after that
No
I
worries,
couldn't
no
get.
worries. You are a working
Yeah.
professional, right? You take that
Yeah.
privilege. Like sometimes you drop this course, and we will not worry about it. Actually, I think why I am saying this is maybe some of you will have some difficulties. Maybe this is the right time because it's the first session. I can mention one of the cases. Uh, One of the students in the last semester, just 2 weeks before he had some personal emergency, he was in kind of dropping actually with some wrong notions. Then I told him, this is what this, I just keep on messaging him. Finally, he's able to appear for all the courses and got B in 3 courses, B minus one in other course. Right? So that's why what I suggest is in between you may have some difficulty. And if in that case you can drop one course like that, right? Don't trouble yourself with too much thing of the thinkings, right? Otherwise, what happens? One more semester you have to spend. Not a problem, right? Yeah. Okay. Now let us have it the introduction kind of thing. So, what is deep learning? Already you are having machine learning, right?
connected neurons.
Why we need to go further? Now, just maybe I think already you had the introduction. In machine learning, you had some discussion related to data related discussions, right?
Yeah.
Data, right? Data, I think maybe something like a labeled data, I hope.
Yeah.
Yeah, correct.
Maybe some of the, sometimes I will peep into a machine learning course, don't think otherwise, because we need to connect
Supervised.
that dot with. So labeled data, unlabeled data, that is where supervised learning, right? Supervised learning, some
Right, sir.
terms that use supervised, unsupervised. So
Basically,
labeled
deep
data.
learning is for unsupervised learning.
Wait. Wait. Because ML is also having unsupervised learning, right? If you see the course handout, in your ML course handout, there is some one module on unsupervised learning where they talk about clustering. Right? So this is labeled data, unlabeled data, supervised unsupervised. Not only restricted to machine learning. In general, when we talk about data, This is how we categorize data, right? Labeled data, unlabeled data, right? What is the difference between these two? Any?
Labeled, we know the
The
output.
label data has a
Unlabeled,
target defined.
classified. So we classify the data like.
They
Labeled
tell
means
it that
general understanding for me is
We
data
know
comes
the
with label,
output.
headers kind of.
Level will have outputs.
Yeah, yeah.
We have
We
defined
know the
labels,
outputs actually.
titles.
We have a defined pattern and like, okay, it will be well
Yeah,
structured data.
yeah. So it is
So,
something like because my core talks about this y equal to f of x. Now it is very clear, right? Suppose if you take y equal to f of x1, x2, so on, xn, something like this. It is very clear. These are the inputs we give, and this is expected output, right? It's very clear, very evident, right? So this is one aspect. Suppose unlabeled data, so we mentioned here very clear. Now, can we give any value for y? No, right? X1, x2, we can take any value. Accordingly, we'll get y value, right? This is one. Other aspect of it, suppose if we had something like this. Can you see what is the input, what is the output here? Is there anything like input, output?
No, sir. No, we don't have
no,
a defined value of y. Yeah.
I think that
no.
actually is the other, but here I can write, we can write it. If you agree,
X1,
I'll
X2.
write this as something like this, right? Now, these are the inputs, right? This is the output, right? But restricted, or we can write same as like this, right? So as if as it is not coming with any label. We can do it something like. I think that is the basic difference when we work with the labeled data, unlabeled data, and particularly if we take labeled data, what we expect, we should have some clear understanding of this is right. I hope someone has to give this
So,
data, right?
sir,
Someone has to give the 1 minute. Someone has to give this, right? Then only we'll take this to our ML algos, right?
Yeah, right.
I hope you agree with this, right? Someone has to give. It is like some 20, 30, 40, then this is 10, something like this, right? Something like this, right? Someone has to give this data, then only we'll work with it, right? Now, then we'll take this to ML algorithms and we work with them, right? Now, one difficulty with this is, suppose image is given. Image means I'll give an image. Then what I expect is image means I think we know image is also a data, right? Image is also a data, right? Then I want to know, is it a cat or not? I hope I'm not confusing you. So now instead of this, I am having this image. What I expect is whether is it a cat or not. Right? Now I want to go with algorithm. Algorithm requires this. Now, when we work with images, what happens is your cat may be sleeping here, right? Your cat may be dancing here. Right? How to understand it? And second thing is, now cat means what are the features which defines cat? What are the features it defines the cat?
fur, tail, eyes,
Color,
nose,
Nose,
Eyes,
tail.
number of eyes, number of like this, right?
four
Now
legs.
someone sits with this image and convert that image into the data. Then we can work with ML algorithms, right? Like two eyes, four legs, color, then it is a cat, right? Only same eyes, only two legs, etc. etc. This is not a cat like this. Right? So what I mean to say is someone sit with data, this is what is called a labeling. And while doing so, the problem is maybe the cat is sleeping when only you can see only two legs, remaining two are hiding somewhere, right? So having data in this format is a problem, right? This is one example, right? So that is, but ML always looks for this. ML always looks for data which comes very clearly, then it will work very well. But here, when particularly image, an example, if we take, this becomes a big task. That is where we look for deep learning. One of the instances. Okay.
So it
Right?
is mostly used
Sir,
in image recognition. Is it like that, sir?
Yeah, image recognition, translation, blah blah blah, blah that kind of thing. All not only image object identification, right? Image classification, all those things, right? Whenever it comes with the image, right? So this is required. That is one of the use case where we have to look towards deep learning or DNN architectures. Okay.
Sir, can you repeat? You mentioned that someone has to feed the features of cat the data. That means
Hmm. Hmm.
the data.
So it
Yeah,
means that
converting.
they
For
both
me,
go.
no, for my ML algorithms, I require this. What are your features which helps me to identify is it a cat or not, right?
Yes.
Someone has to do, right?
ML. How
Then ML is good to work. But one someone has to do, and also it is not a structured, right? The cat can be in some other form. Maybe it is a cat in Australia is different. Cat in Pakistan may be different kind of thing, right? Different versions will be there. All those things becomes a confusing factor, different difficult thing for us to prepare the data. And this is one use case, right?
so this means that either someone is facing difficulty to feed those features into the data. Then if someone can, then there might be different cat in India.
That's why someone needs to know the knowledge kind of thing, right? Knowledge, understanding, then prepare the data. That is a challenging task, right? Particularly image related and all, not only image. Suppose if you take the translation, language translation. Maybe some of the points may go overhead, but still where there's a just introduction. Image, what I am trying to say, why we need to go beyond ML is the point of discussion here. Language translation, if you take, right?
Yes, sir, got it.
I'm taking the class. 1 minute, Krishna Kumar Ranjan. I'm taking the class, right? Now, in case of ML approach like this, right? If you are going for prediction or classification, is there any rule that you have to give this first data only, second data only? That data has to be given in the same format kind of thing.
No.
Is it so? No, right?
No, no.
No, right? Can here also this is data actually. This is a feature. Actually, this is x1, this is x2, this is x3, this is x4, this is x5. Can we do the same thing? Can we do the same thing like this?
No, it
No,
cannot
right?
be.
It is very
No.
important that I then follows M, follows this, follows this. I think that is not okay with ML, right? ML is not having that aspect, right? I think like this, like this.
Order of inputs matter here.
Order. That is what is called a sequential data. Sequential data. Not only this, I think if you are familiar in terms of stock market data. Stock market data. Not data mining. Not data mining is something you have to mine it, but here it gives the patterns right out of it. Sequential data. One example is if you those who are familiar in terms of stock market or time series. I think these are maybe many are there. Maybe way forward we'll try to understand. I think these are the maybe two cases which uh, helps us to understand why we need to go for deep learning. Many are there, but these are the two use cases. I think we understood that. So we need to go beyond our ML architectures, beyond ML architectures. Okay. Okay. I hope maybe we'll add some more points later. And what is the basic idea behind this entire deep learning or deep neural networks is the artificial neural networks. Okay. So this is the basic idea behind the entire course. What is that one? So here, so they try to mimic how the biological neuron works. So biological neuron, how it works, that is the base which triggered the discussions what we are going to have, that is neural network architectures. Do you think is it the new thing which emerged out recently because of the AI revolution?
No,
Any
this
idea?
was
Like,
no. It was there, but it emerged
No.
after AI boom only.
it was there even, maybe you are not aware of, even 1960s, 70s, even 80s also. If you go take some universities, they had a course on neural networks. They had a course on neural networks. Maybe some of you might have studied in your at your graduation. Neural networks by B. Narayana was very popular in some of the universities. Not now, recent, almost 20 years back itself. Right? So then after so many years back only, they tried to mimic the working of biological neuron and they created some architecture for it. Now, why it became so popular now is because of many aspects. One is computational aspect. Is there any aspect? One is computation. Now, computation is not at all a big problem, right? And also, storage is not a problem, right? And also the data is not a problem, right? Available now. I want earlier, if you go back 30 years or 40 years back, if you want to work with any algorithm related to voice, it was very difficult to have a corpus to work with data, right? This was a very difficult era that was. Now advances in many aspects like computational storage, availability of the data, etc., made again the neural networks as one of the important aspects of the AI revolution. Yes. That they have taken from human capabilities only, no? Okay. Yeah. I think that this is what some of the points here. Okay. I am not going through each line, sentence, a line, word, no, right? Just I will give the summary of the statements. Okay. Now this is something. So the combination of many things, AI, ML, this, all are having some joint collaborations. Yeah, cloud, not only cloud, Vadusha, right? Not only cloud now, even data centers, servers, data centers, right? Now, if you see LLMs, right? What is the base for this LLM? The availability of data centers and computations, right? I think this is something which would try help us to understand what is superset, what is subset, right? Yeah. So I think some like what
Sir,
AL.
one dot like I saw in some other slide like data science is on top of artificial intelligence. Like data science is superset of artificial intelligence, but here if we see under artificial intelligence we have data science.
Here actually, suppose if you are, even data science is a bigger thing on which everything work. If you see, that's why it is overlapping with all these things, right? Now, if you take data out of it, nothing works, right?
Correct. Okay.
Yeah.
Yeah, now I got.
Yeah. Without data, nothing works, right? Data is very important, right? That is what I mentioned. The availability of data is something which revolutionized the industry, right? The importance of
Yeah.
the data is right now. If you, I think maybe it is irrelevant, but still I'll take why data is very important at every. Right? The first lockdown, we are very disciplined, right? I hope. Even those are bad days, but still good experience. No uh, generation had that experience, right? First lockdown, we are very disciplined, right? Second lockdown, no, right? What is the reason? Any first lockdown, everything. Now we stopped papers, Swiggy, Zomato, everything we stopped, right? But second lockdown, no. And the channels and all started blaming the people, saying that they are indisciplined, etc., etc. Any guess on what is the reason?
We learn about
Casualness,
disease
Is
and
learning,
it
we
so?
got information.
Yeah, here data
learning.
availability, right? Data is not available, right?
It was
Even
first time.
doctors, first time. That's why doctors are not aware. They just trial and error only, right? That's why you might have listen like paracetamol, etc., etc., right? My understanding is by the time when the second lockdown happens, data is available, right? Data is available, right? That is actually, I think, what I mean to say is that is the importance of data. So by second time we had experience. Okay, so newspaper, no, it is not the cause, right? Like this. So the data helps us to take decisions, right? Yeah, right. Nice. So what deep learning all about is the subfield of machine learning. Right? So here, why this one is when we talk about deep learning or deep neural networks. So learning happens similar to artificial neuron, right? Similar to artificial neuron. And why this deep comes for the discussion. What is this deep indicates? What is the deep stands for? Any guess on this?
It's a depth
Depth
It
of the
knowledge.
goes,
knowledge. Okay.
it goes 2, 3 layers deep.
Multiple
Layers
layers.
of
Deep
data.
analysis.
Large
Okay.
data.
Hidden layers of
Large
the
data.
network.
Learning with huge data.
I don't know anything now. Just today, the first class for me. Then you are saying layers. Then very
Base
simple.
will go.
Very simple. How the kid starts learning, right?
Think it from various perspective of a
Learning
Kid.
with huge
particular
data,
object.
right?
No kid.
Explain
Now
it.
simple. Kid. Now with that small
Experience.
kid, you start exploring like.
Try and error.
Start from zero with the experience.
In-depth analysis.
Yeah, yeah.
Learn
No,
from previous data.
that only deep or depth.
Observation.
Now, some kids, that is what we like. Some kids, if you show a picture and say that, Betty, this is a dog. Next time, or if you show the dog, next time they will identify say the dog, right? Now, sometimes you might have seen every time you say dog, even cat also, she says it is a dog, right? Then again you will tell, no, no, beta, this is dog, right? So here with the first instance, they are able to, right? Otherwise, second, third, keep on doing. That is what is deep or depth. Right? So first they will call all as auntie, right? Or all as like whenever they say ma, right? Like keep on repeating the same, then they will understand, right? That is what is meant by deep or depth, right? So that is what our friends are mentioning, layers.
Well, can we say that refining at every step?
Refining, no. Refining, that is reinforcement,
Reasoning.
right?
Reasoning.
I couldn't get you exactly.
I
No,
said,
okay, we'll just we'll anyhow we'll have the more discussion. Layers means like a layer. I said the first read is layer. Suppose if you give a book, first read I am not able to, then again I will go for a second read, right? Third read, like this. So this is actually how we understand deep or depth, right? Now, how to define this? That is the challenging thing, right? Suppose you are very good in fiction novels. You are a very good reader of fiction. How much reads you require to go complete a novel? One
Isn't
read,
it
right?
like same like your reinforcement learning only?
No, no, I am not using the term. Suppose you are very good in reading fiction novels, you like it. So a book is given, one reading is enough for you to go through it, right?
Yeah.
Right?
Yes.
Suppose non-fiction is given.
More than that.
2-3 readings.
Yeah,
Yeah.
we'll have
Depends,
to
right?
go for
That is what
multiple
depth
readings.
actually. One reading, so one layer, one that is right. So maybe you require more, right? That's why is still why this is a separate subject, separate discussion is. So there is nothing like we can define. Depth depends on many aspects, right? Depth or deep. How many readings you require? Is there any thumb rules to fix it? No, right? Maybe you require one reading, I require 10 readings, right? So that is what is a challenging task. That is what we are going to see various aspects related to this. Okay. I hope all the sentences are clear. Any sentence in this slide to be discussed in depth?
Yes, sir. So basically, in when we are saying deep, it means we are trying to get more number of data in a better way, maybe in a proper segmented way to understand the problem. Because I'm not getting it. What's the
No, it
difference
is
between
not
the
data. It is not data. It is architecture actually. How deep we have to get into.
and what's the difference between the reinforcement and this one? And the reinforcement also we get the if it get rewarded, it will go ahead. Or if it get
Reinforce, and I want to trouble with all those things. Reinforcement, you will update yourself in between with experiences, right? You will reinforce the learning in between, right?
correct.
It is not so here. That's why.
But in the dog and cat wala example, we are doing the
Hmm.
same thing only, right?
I don't want to push more complexity. That's why we'll have it. There is a line between these three aspects, right?
Gotcha.
Maybe for us, both of us, it may be interesting topic. Yeah, just it's the first day now. So maybe still many people are not clear on what is MLDL, right? We'll have it later. I will try to make it. I can put, but it is too complex for some, right? So I think some of the aspects already we discussed, right? And data storage, right? Then quickly we can have large amounts of data, right? I think this is one of the important aspect of like images, text, audio, video is one of the important aspects which forces us to look beyond ML algos. And this, I think, already data storage is not a problem. Computations not a problem, right? CPU, GPU, clusters, distributed computing, parallel computing, distributed ML. Even what is the latest addition in the computational aspect? What is the latest addition in the computational aspect?
Agentic
TP,
AI.
cloud.
Computation. I'm asking.
Quantum, quantum
Quantum,
computing.
Quantum.
TPUs.
Yeah, TP is already where it is. Now it is moving towards quantum computing, right?
Qubits.
Yeah, qubits and all part of this quantum computing, right? That's why that is also another reason where it is changing like anything, right? So algorithms, so learn by examples. I think these are all the
Sir,
various algorithms.
when you say cheap data storage means it's affordable now, right? Affordable.
Yes, no.
Okay.
Earlier, you think of right. Uh, mm, when you want to store something, you have to buy or what is that one? Pen drive? No, pen drive, right? What is that?
Yeah, memory card or pen drive.
Memory
SSD.
card. We used to
Floppy,
be.
floppy
I
disk,
think you might have seen
floppy
your
disk.
colleagues as having luxury. They will be given this storage devices where I am not. Right. So in organizations, whether you are aware of it, some some level only people they will be provided this pen drives kind of thing. Others no. Now, do we have see that luxury? No, my mobile itself more than a laptop, right? Right? Yeah, and having that pen drive itself is a luxury. People feel like I'm having this storage device. Now we don't require anything. Our mobile itself is a big storage device, right? That is what I mean. Suppose if this is costly, suppose storage is costly, then it won't be so popular like what we have been seeing, right? It's not. Yeah.
Yes, yes.
And one very good important thing which whenever people says the open source thought process is actually one of the basic aspects which revolutionized many things, right? I hope this is what I feel in general.
Yeah, correct,
Yeah.
sir. Like, okay. Yeah, if things
Most of
are
the
like
things are currently with open sources.
Actually, in this aspects, actually, we need to appreciate the generation who opened that thought process. If you ask me, we were from the generation where everything is hidden. Don't want to share the research what I am doing with the next desk itself. I don't want to discuss what research I am doing with my colleague who is a close friend of mine. Also, I don't want to discuss. I think nowadays we are not having that, right? That is what Google research they published this paper is a openly available. They publicized this paper. Then based on this, many people worked on it. That is where we had this transformer architecture, then chart GPT, LLM, all those things actually. Attention all you need. Yes, yes. Yeah. That kind of thought process is one of the things. Otherwise, if it is attention, all you need is a paper, research paper by me. I won't publish it. I won't publish it. I will give it to some Springer where you have to pay $1,000 to buy the paper. It is closed in it. Right? I think that is one of the important aspects. That's why you see the developments that happens in the softwares also, right? Python, right? Yeah. Okay, I think this is some how scaling aspects of deep learning, right? I think some and some history you can have it the aspects. Now one more because it's the first we'll have a general more general discussion. So one is suppose you had a customer project. You had a small startup. It's not a big small company. You had uh, a project where it is something to work with images. Right? And maybe image classification or anything like that, or object identification, etc. And now, I think many of you know when we work with images, we need lots of computations, right? Lots of computation, storage, etc., etc. But
Graphics card.
yeah, it's very difficult to have as a small company, right? Then how to handle it? Right? Suppose Google is Google or Meta, they are in a position to handle all those aspects because they are having that capabilities, right? But I'm not having, right? But I'm having a good idea. I'm having good idea, good algorithm with me, how to work with it, right? Because I'm not having that computational, right? I'm not having TPU, GPU kind of thing, right? That only the big organizations are having TPU, GPU, those things, right? And do you think that I should not get into the projects of this kind, right? So that is where the one of the other philosophy is transfer learning.
Is it similar to MCP module context protocol?
I don't know actually. Otherwise, transfer learning is something where already we are having some models available. Uh, maybe it is a Google or Meta or any, they already work with many algorithms and they shared it. Just use it, modify it and use it. We need not do all the computations required. I think in the last module, we are going to have some discussion already in this. Right? So this, like here the idea behind this is, suppose if any your kid wants to learn the motorbike, then first what you suggest?
Learn
Bicycle.
Right?
borrow from someone and then
First bicycle only, right?
Yeah, right.
I think that is what is transfer learning. So have that knowledge out of bicycle riding, then use it in the context, right? Why can't directly bike riding? That is right. So same here, there are already developed
But
models,
nowadays,
algorithms.
the people used to do that directly.
Maybe where the parents are so confident,
That's
or
why
the
accident raise.
or the kids are not listening to us, right? Now there are many already worked algorithms, right? Just take them and reuse it. That is where we can avoid all those computational related bottlenecks what we are having. I think this is another, uh, maybe I don't say that it is algorithm, thought process, transfer learning, which revolutionized the industry. Yeah. I think they can go through it, who did what. And if you see here, um, maybe last before year, if anybody followed Nobel Prize, who will get one, I think physics professor who is around almost 90 years, he was awarded Nobel Prize for what? For the neuron architecture. Almost, he is 90 now. Right? Okay, yeah. And maybe this guy, Leonard, maybe some of, I think I follow him regularly. CNN architecture is proposed by Anne Lukun. Recently he left Meta and joined somewhere, started his own. Right? Like this, you can go through some histories and so on. Right? Okay, applications of deep learning. I think many are there now. Now I think is a common, right? So one is speech recognition, right? And this is a machine translation which we have been using. What is this all about?
image classification.
Object detection.
Object detection.
Object detection.
Object detection.
Any wow application of this you might have seen? Actually, it is a wonderful application of. Here
Autonomous car.
actually,
No driver.
Self-driving car, yeah. Self-driving.
Level
car.
mapping.
yeah. Actually, now actually I will, as I was surprised actually. Suppose if you give the data, I can do all the things I can work with and I can present. If you observe IPL, I think many wonderful things we can observe, right? One of the things is, I think whenever they X moves, right, they will show these boxes kind of thing. Even the names also, nobody knows, right? Nobody is sitting and finding out who is that person, right? Automatically the algorithm identifies who is standing in which place, right? I think that is one of the beautiful things. Okay, yeah. I think some of these things already familiar
Sir, I
to.
have one quick question.
Yes, please.
So right now you showed previously that Microsoft AI is surpassing humans. Now driving cars are there, any other things are there. So actually, means we all are in AI ML course. We are doing so much things, but means we are currently learning, but lot many things are with these companies. So how it is going to be fruitful if we are learning right now AI/ML, or how this deep learning and machine learning, because these companies already have too many things. Even if currently at work, if I'm using Chat GPT or that Codex, if from the OpenAI, it is doing lot many programs on its own. So where we are going to be after this course, or how this course will help us in future, or where we are
That
heading?
may not be able to give the answer exactly. Suppose
Actually,
now you are using ChatGPT, right?
uh,
Now you are heading one department, and maybe you are a fintech company.
hmm.
Are you going to allow are you going to allow your team to use ChatGPT?
No.
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 Then
No.
you don't want to make use of the advances in technology for your organization.
No, they will have
We need
approval,
to
right,
set up
sir?
our
No,
own
typically
LLM.
That is
in
where
fintech,
you can no, you can have your own application, right? That is where agentic AI people talks about, right?
Yes.
so to some
Specific.
limitations, like okay, we can use, but like okay, not to entire thing, like okay, in fintech or like okay, medical
Then,
areas, right?
then you can ask your team to let us have our own application, right?
Yeah, that's
Yeah.
correct because data privacy is a concern in
Yeah.
enterprise
Now,
level.
why I'm saying is even we are at university, we are not. Now I'll tell at university now. As a fact, now I'll as a suppose I am a HOD or the principal of the college, my university. I will ask all my faculties to use Chat GPT or any of those things to prepare question papers. Right? Is it okay?
No.
Can I
No,
ask?
it's not.
Then that means you don't want I teach all those things, but you don't want me to use any of these things, right? I'm teaching all the advanced topics, this, that kind of thing, but I'm not using it, right?
But
Then
we are having Copilot now, sir, within Teams. Then you have some
but
terms
the
and conditions
Copilot
with
won't
Microsoft. Yeah.
help me to prepare question papers, answer keys. Even I think that what I mean to say is here at university at Bates Wilp itself, we are having a separate department. We are working creating our own applications. One is QP generation. So it's nothing but we are having our own LLM actually. Right? We'll prepare handout. We'll give the key instructions. It will prepare question bank. It will prepare question paper. It will give answer keys also. Right? Not only this. Whenever I think we had a dissertation, we upload dissertation. I give rubrics. It gives you the score. What I mean to say is we are not using openly available applications or whatever it is. We are having our in-house. Right? So now if I want to have now I need this entire knowledge, right? Is what I feel. Right?
Correct. Agree, sir.
And one more thing is two versions always. One is I don't require anything. I'll make use of whatever is available and proceed. And I will try to understand everything behind it so that I can build new things, right? Right? I think
Yeah.
I mentioned I may not be able to answer your query. Right?
No
Sir,
problems.
sir, I have just one question that
Hmm.
LLM which you are talking about. So I suppose the one which you mentioned that transfer using that only you did, right? Means from Google or Meta, you got the basic model and that on that you built it. Is it something like that?
No,
I
no,
was just
separate, no,
curious.
separate. We know the architectures, right?
Yeah,
We had
yeah.
our own GPUs.
Okay. Okay.
But still,
Very nice.
but
Very interesting.
actually, it is not that great because you know the training is required, right?
Mhm.
You have to train it, then only it will come out. But that's why
Exactly.
university is forcing us. You always use this. You may not take it completely and give the paper, but make use of it because training is very important, right? Yeah. Okay. Yeah.
Correct.
Sir,
Got
is
it.
that accessible to students also, like
No, no, no,
via
no, no,
API or
no,
something?
no, 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 no. Maybe way forward because once we are okay with that, then maybe we expose it where you can upload your dissertation and validate it. See your own scores. Right? Yeah, Rupaji. Yeah. Okay.
Sir,
Now, hmm.
sir, how to differentiate applications of deep learning and machine learning, sir? They both look same.
I think I'll come to that point. Yeah.
One question. Again,
Maybe when we go for the third module or second module, after having the basics of neurons, etc., when we start linear regression models for deep learning, I think I am having that plan actually, because it's always a uh, dilemma whether I need to go for ML or whether I need to go for DL. Right? That I'll make it way forward. Okay. Yeah.
so in that image earlier you showed, so you said
Pardon?
that image is object
Hmm.
detection. So
Yeah.
how is object detection different from image classification?
Object detection, image classification is simply if you give an image, you are expecting whether it is a cat or not kind of thing is classification, right? Here you give an image and expecting the algorithm to identify what it contains, right? I hope.
But aren't we classifying like in that image?
Not classifying.
Person,
You give some restriction, just like now one application what I mentioned is in airport they will try to identify the terrorist and all, right? They will have already the criminals database, right? They map this criminal database with the database at airports. What it do is they try to identify whether this criminal is there in the airport database, which is a live database, right? Live streaming. Like identification whether this X is there in that live streaming data or not. That's not a classification.
so if it is live streaming, then we say okay.
Like, yeah. So some of the applications here, maybe what our friend asked, maybe one we'll try to figure out. So here, real estate, right? I think today morning itself we had a discussion on this probably. Yes or no? In ML you had this, right?
Yes. In FML.
Yes.
I think this
Yes,
this you can't skip actually. It's a what is the term that they use? Regression, right? So
Linear
real
regression.
estate,
Numerical data.
linear
Numerical data regression.
Linear regression.
regression, linear regression. So now already you learned in the morning session we can use ML algorithm, right? We can use ML algorithm. At same we can use the basic or standard CN neural network algorithm. Now the question comes, our friend asked, right? So this what we call as a project came from one of your customers, right? They gave the data to you. Now you have to take a call whether you want to go with the ML or NN. How to take? You got the point what I am trying to write? Here we can use ML and also NN, that is real, right? How to take a call?
It's a raw data, that's why we should go for DL.
Okay.
Sequential data maybe.
But the
Depends
real
on
estate
how we
data
are
is not
giving the
sequential, right?
inputs. Based
No.
based on this knowledge what
Fine.
we are getting from this, right? His question
Mm.
was what we are getting by doing this, right? Why we are doing this when already tools are available.
I feel on the complexity of data we can decide if we have a like a very
Yeah. That is actually that is what I think way forward will have. I mentioned that later, but the slide came. Depending on the complexity of the data, we have to take a call between ML and DL architectures. Right? Depends on the complexity of the data. That's why now DL is more advanced. Something saying if it is DL is more advanced, why should I learn ML? Anybody got that doubt? DL is more advanced is something people are feeling, right? If advanced is there, why should I learn ML? Do you want me to learn ML algorithms?
ML will be
Because ML is
Advanced
faster.
has to
Less resources.
Based on the complexity, we use what is required.
So I'll give you
Cost.
in a lighter note. I'll give an example. Lighter note. This is many times I'll give in my other course also. Why should generally this problem comes already Chat GPT is there? Why should I learn something, right? This is advanced. It depends on the application, right? Depends on, for example, I'll take maybe Apollo. For example, I'll take Apollo, Banjara Hills or Jubilee Hills, whatever it is in Hyderabad. It's the best hospital, suppose I say. It's the best hospital if I click like the advanced, etc., etc. Now today I had a cold. Do you want me to go to
no.
Sir.
No.
Nearby clinic.
Clinic.
not
General
clinic,
physician.
even not general physician, the local medical shop guy in
The
the
medical
doctor
store,
works.
Yeah.
Right? Then that is actually right. Why you are not going for more advanced hospital
Cost, price.
like right?
Rolex.
I think that's why ML is required, DL is also required. Depends on the case, use case, requirement. Many aspects comes for the discussion to take a call whether to go with ML or DL. Right? I hope that depends on many aspects of it. Okay, yeah. I think some application like photo tagging, anything that works with images, right? Either photo tagging, object detection, object classification, anything, generally CNN, right? And other things, one minute. The other things, speech recognition, that is audio, right? Translation, right? So what is the unique feature of it? They are sequential data, right? Audio, speech, if you want to convert it in the text, where is the sequential data, sequential models are required. These are some examples, RNN architectures we use. And
Sir,
autonomous
RNN.
driving, RN?
RNN means R for
One architecture,
RNC.
recurrent neural networks, recurrent neural networks.
And CNN.
I'll come.
Okay.
Convolutional.
Okay.
So in the first one, in ML, we normally define the X and Y. Do we have to define for the standard NNN as well?
No.
Okay.
I think though maybe if you are from EC, electronics and communication, I think you will enjoy this. Already you worked with convolutions, right? Convolution is one of the popular things which communication engineers do. Okay, yeah. So some application. I think this list is vast. Okay. I think some examples. I think so predicting tomorrow's weather, right? And question answers, objective. I think many of the recommendation systems. There are all more and more applications. Nowadays this list is exhaustive, right? Now what are the key components? Right. Yeah. In general, what are the key components for even not only DL, ML also data? One minute. I'll push some discussion related to ML also here. How we work with data. I hope some of you may be knowing our discussion. We divide data into this, right? Actually, whatever the data is there, we won't use all the data. We divide it into training data and testing data. Training data and testing data, right? So what we do with the test training data. So whatever, suppose generally what we do is mm, no exact thumb rule as such. People take 80% of the data into whatever the data we are, 80% will push in this 20%, or some people goes for 75, 25, like this. So why we need to do this? What is this we are doing? Why we are dividing data into two chunks? And what is the use? What is the purpose of doing it?
Efficiency.
So
To
that
train the model.
to accuracy, to the accuracy.
Hmm?
Train the model and
To the
get the
accuracy.
output.
Yeah, for better
Accuracy of the
performance.
model.
Okay.
So I think yesterday we learned something like if the generalizations are applicable on the training data, then the test data being derived from the same data, the generalizations will also be applicable to the test data.
Okay.
Maybe
Okay.
We
What
are
is the
trying to
advantage?
do feature engineering. We are trying to do feature engineering here.
Feature engineering already
To
done with, right?
to handle all
Okay.
the
No,
edge
very
cases
simple, very simple.
actually.
Maybe I'll make it very simple.
Mm.
Why this is similar to those who are having kids studying in the so-called corporate schools, +1, +2. You might have seen what they do, weekly test kind of thing, right?
Mm.
Weekly test, monthly test, etc. Right?
Yes.
If you go back to 20 years back to line, if those who studied in 90s and 2000, maybe before 10 years before, do you have this kind of doing the things?
No.
No, right?
Look.
Sup- means if you are in +1 or +2 or any class, the academic year starts, and maybe after 3 months you will have a quarterly examination. After 6 months you will have what is that one? Half yearly at end examination. Before that, nothing like quarterly, half yearly. After the end of the semester year, you will have examinations, right? What is the difference? Now, every week they will have a training, right? Is the classes will be held. At the end, they will do the testing, right? What is that they do attain get out of this is, so after training they will conduct test. Suppose if the student's performance is poor, then no response.
They can
That
they
PTM,
will
That's
train
what
the
we are
model.
saying.
They will
that
give
P,
more focus
that
on
PTM, that PTM is all about, right?
More
yeah.
effort.
That PTM is
And
all about.
feedback,
One
retrain.
is
Continuous feedback.
one is they do they take care of. Otherwise, they will try to complain to parents against your kid is not doing well, right? That is what actually here we'll try to understand the data. We'll train our model, and we'll check how this model or model means algorithm works with this data. Then we understand, right? Okay, it is going good. Then you go for deployment. Right? Okay, yeah, that is what training and testing the data. Okay. So that is how we do it. I'll take a simple example. X1. Some numbers I'll put. Something like this. These are some information like I am having. Okay. Then I'll take one algorithm, some algorithm I'll take. I will train it, right? Even while training also what we do is, suppose it is like W1, X1, W2, X2. Then, sorry, these are some unknowns, right? I had some values for this, which I observed or I got it by some magic. Right? Then I'll give these inputs and see, suppose, sorry, from this data, I am able to get some this like. Now, whatever the model we are getting is correct or not, we don't know it. Then we put it with testing data. Already we had some data kept aside, right? We'll see how we do it. Something like this. Now we give x1 value, x2 value, what it gives. Suppose it is 0.8. But originally the data is coming with 1. Right? Now this is 0. And this model gives suppose 0.3. You can see actual value is 1 where our model predicts is 0.8. 0 and predicts as 0.3. So now we'll try to observe actual value, what we had from the data, what we got because of the proposed model. Then we do the analysis. Actual minus or plus, whatever some mechanisms are there. We do the accuracy or error analysis. Suppose our observation is, okay, this is not doing it, error is going more. Then we won't proceed. We'll go back and try for some other approach, some new algorithm, something like this. So that is the advantage with. We'll try to figure out that model or algorithm. We'll validate how it works in the other data. We are happy, then I think we can take a call. I think that is the philosophy when we work with algorithms, right? I hope you got it right. So that's why when most of the times you will hear the terms like training and testing. Okay. Okay. Sorry, I think I forgot it. We'll break for 5 minutes and continue. Okay. Yeah. Sorry, I missed that.
Thank you, sir.
Yes, Padusha. Any?
Hey, hi, sir. So I just wanted to ask, like this image recognition and all, it's already there in small security cameras, right? Like 1,000 rupee ones also. But they won't be using this AI and all, right? In that
Which one? Can you bit louder? Images?
security cameras, like we can see motion detection. If somebody is coming in a specified area, it can detect and alert us, right? But they may not be using this AI, ML and all, right?
Actually, we have to use, no? The automatically detects, right? That is what actually, if you see our cameras in mobile, right? Whether you have seen that Google Photos, if you upload, I think monthly collegium or something like you will get, right? Monthly summary you will get. And also whether you used it or not, it will create folders, right? It will create folder with you and your kid. And when you see it clearly, whenever you take an image of a kid, it pushes it to your kids thing, right? Whenever your
Groups the
image is,
people.
it automatically do, right? That is actually AI capability, right? So it identifies that this belongs to you and it will push us to corresponding cluster.
Right.
That's why I think when we talk about images, it should not get confused with two terms. One is image processing and working with AI capabilities on images.
Sir.
Yeah.
Sir, in this example, right, in the chart that you given y cap, what is this y cap? Like, how do you get this?
This
Y
is
cap.
we calculate. Now, this is the model or the algorithm we are proposing. How it works. How it works. So these inputs we give, right? These inputs x1 is what the value, x2.
Right.
Then we are getting this. This is called as a actual, in machine learning terminology, y is called an actual value. That is coming from data. Generally, we denote by y hat is predicted.
Okay. And okay. Y is the ideal value and okay.
Ideal actual value, which is
value,
from the data.
Okay. And y cap is the predicted value. So
Predicted
minor,
value.
okay. Negative, that's okay. Error.
Not only negative, some comparison analysis between actuals and this we do, right? That is what the basic philosophy behind fixing the algo.
Yeah, so it's kind of like yesterday you taught, right, the deviations. we are in the statistical analysis. So we basically analyze from here also, right? How much is getting deviated, and we got
Yes,
that
yes.
line.
It's similar to that, but here different context will come now.
Okay.
Suppose if you take very simple example, uh, very simple, what doctor do when a patient goes,
you ask our symptoms.
Diagnosis.
that is symptoms means input data.
Input, yeah, correct,
What
correct.
we expect, simple example is fever. Is it a fever or not? Right? Is it a fever or not?
Right.
Right. Now, how you say that this doctor is good?
If he gives the medicine and it got
The
we got
performance
fit
right
in
now.
the
Suppose
performance, yeah.
X1 went with, right. He is having a fever. He identified and cured it. Right. X2, like you will see, out of the 10 cases that you observed, actually he treated well with 8 cases, right? Right?
Yeah,
Out of
right.
10, in case performance of doctor in terms of the maximum, right? Suppose if it's 2 by 10.
Right, right.
Similar, see, doctor is like a classifier actually. Doctor is an algorithm.
Okay.
So we have to assess the algorithm, performance of the algorithm, right? That is where actually is fever, but doctor says no. That is a error, right?
Right, right.
Like,
Yeah.
like this. Here actual value is 1, but our algorithm says 0.8. That is error. Here 0, 0.3. Now we try to understand the error to figure out the performance of the algorithm. Yeah.
Thank you, sir.
Hello.
Yes.
Uh,
Yeah, please.
so this is a general question. So when we say I'm new to AML concept. So when we say we train like machine to learn from the data, but when we are going with the theory like supervised learning, anyway, ma'ams then started with the other the unsupervised learning or reinforcement, those things. So but still I'm seeing like in the supervised learning we are only providing the output, right? Somewhere this the learn from data for the machine, it really doesn't making much sense, right? I mean, we I mean, is my question is clear, sir? Like, so when we say we train a machine to take his own decision or like learn from the data.
Yeah. I think now maybe I'll take a simple. Now
Or
ChatGPT
is
is
it,
there, right?
sorry, is it
ChatGPT is there,
early?
right?
Okay, sorry. Yes.
ChatGPT is there, which we are
Yes,
using.
sir. Yeah.
Now you'll pose, you'll give any prompt or a question. It gives the
Right.
answer, right?
Right, sir.
How it got this capability?
Uh, Maybe because the prompt they
No,
might have
actually,
okay.
we are using. Otherwise, they have done this, right? They have done whatever we are discussing.
We
They
developed the
identified the
model.
algorithm. They give all the inputs and trained it. That's why now you won't see much mistakes in the responses that you get out of ChatGPT, right?
Right, sir.
No, otherwise I'll give. I think I understood it. Now, are we doing anything to identify spam mails that we are getting?
No.
No, right?
No.
How it is happening? Automatically it is getting into spam folder, right?
All right, sir.
How this is happening? I'll tell you. Actually, before this, whether you are maybe, I remember 10 years or 15 years before, when the evolution started, whether people, those who are familiar, whenever we get a mail, it used to ask us actually. People who are familiar with respect, it used to at the beginning, it used to ask us like, is
Yeah,
it a
कोई बात नहीं.
is it a spam or not? It used to ask us actually. Now over a period, it understood what comes under spam, what comes under uh, not spam, right? Right. Now nobody is sitting, right? Nobody is sitting and do the categorization or classification, right? That is what. Even ChatGPT also, they had the algorithm and they find and tested the algorithm which we are using. Now, nothing to do with, right? So simply enter, you will get the answer. But how to build it based on the algorithms, right? I hope I answered your query partially.
Somewhat, sir, but still, like the part where machine gets its own intelligence, right? So that's where maybe I mean, like maybe in the coming days, I will once we start.
Yeah. Sure. Now the core components, obviously, these things, not only ML. I
Synopsis
think
पे
we can
बंदा
start,
मत
right?
चले तो बता गया.
We can start now.
Yes, sir, please, sir.
Now the core components.
सर्च करना पड़ेगा इसके नाम से LinkedIn पे प्रोफाइल होगा.
The core components
Vivek
of
Suman, can you
not
please
only.
go on mute?
Yeah, I muted. So one is anyhow the data, right? Data is required. And the model means the algorithm. That the objective function, what is model or algorithm, almost similarly I use, and the objective function. Objective is a very important thing. Very simple. Now I take the classifier as an example. I hope you understood the differences, two things, right? Regression and classification. I hope.
Yes, sir, it's clear.
Clear, right? Regression and classification. Now I'll take a doctor as a doctor is a classifier, right? Doctor is a classifier. You give all inputs, then he will tell whether this is equal to yes or no. So this is equal to yes or no is a class. I hope you might have heard of this term, right? Binary classification, right?
Yes, sir.
Binary classification means it will have two classes. Two classes. In this case, this is equal to yes. This is equal to no. Now, what is other multi-class classification? Any idea?
Image recognition, like they will tell us
In
what
this
kind of
context
image.
only, I'll take yes. Fever is yes. Now, doctor telling is it a viral fever? Typhoid? Malaria, I think. Now, if you see how many classes are there here, for example, these 3 classes, right? Like this, it may be another 4 class. More than 2 classes, then it falls under multi-class classification, right? Only 2 classes, that is the only binary classification. Okay? Now, so how we decide or how to say whether doctor is good or not? Just now I explained to our friend.
Based on the diagnosis accuracy.
Feedback.
Right? Is performance. Performance means curing the disease, right?
Based on
Identification, curing the
symptoms.
disease. curing the disease, right? We won't get into, suppose if X1 cough and with a fever, then doctor identified and yes, done well, right? Like the number of cases, now generally we heard, right, we'll talk to our neighbors that it's a very good doctor. Very good means what is the performance? What is the performance? So majority of the cases he has cured efficiently, right? Same way here also classification or the regression, whatever it is. So we need to identify the performance of the classifier. So how to identify the classifier based on the, that is where the objective function comes for the discussion. So you see here an objective function that quantifies how well or badly the model is doing. Right? We'll have it. We'll see it more clearly what is meant by this. In general, these are the things. Now you might have understood the importance of the data, right? If maybe some of you are already familiar, the success of your proposed ML or DL model depends on what? 80 or 80, otherwise I'll put it in the different one. When you are working with the data for any ML or DL algorithm, we spend approximately 60 to 70% of the time and effort on data only, and the rest on the algorithm part. Why so? Why?
So because if data is not proper, if it is junk data, then the output will also it will not be helpful.
Yes. That is where.
Also, we need to, yes, sir, we need to convert the data in a way that our ML can understand, right?
Yeah, that is various things we do. But if you see, when you go to a doctor, if you give the complete good information, then it helps the doctor to identify the disease correctly, right? Suppose if you are not able to give the complete information to doctor, what happens? Right? Suppose
Wrong
if you simply go
diagnosis,
that
wrong
I'm not
treatment.
feeling well, I'm not getting sleep, etc., what happens? Then if you narrate the things like for last 1 week, what is happening in the morning, evening kind of thing, then it helps the doctor to be more precise in identifying, right? In both the cases, what we are giving is nothing but data, right? How clear that you are, then is very good for the doctor to identify it more precisely, right? Same way here also. That's why almost 60 to 70% of the day work time we spend on the data. Maybe now, maybe it is relevant or irrelevant. What is the time? Okay, yeah. Maybe you will have a challenge actually. Maybe you'll have a challenge. Now you claim that I am a engineer. All right, started learning it, MTech AML kind of thing. Then customer don't know about all those things, right? Customer, what he do is he will come and saying that I am having that data. He will dump the data on us, and he will expect us to create wonders. Right? Simply, he don't know anything. Like comes because everybody is talking about AI wonders, etc. Then he approaches you saying that I am having lots of data, so I'll dump it to you. You create wonders for me, right? Now the challenge is, it is not hypotheticated or fabricated. One of the use cases I had, one of my friends work with one government where they work on something related to farmers. Right? They had MOU, etc. Then the concerned department or ministry, they dump the data with these guys. So generally farming, agriculture, if you see what are the use cases where AI or ML capabilities can be applied in a simple sense is yield prediction, right? Right? I hope, right? Yield prediction, right? Many things are there. Or disease prediction. Like many applications, even water required, etc. Many things we can have it, right? Suppose these are the use cases. We can give yield prediction means in the next coming season, crop season, what is the best crop that you can go for, considering all the previous data and observations, where you will get maximum yield out of it is right, right? Like this. This is what we expect in general. Now, when my friends they've opened the data, then what they say is name of the farmer, mobile number, age, gender, right? And how much land he is having, something like this. Right? Do you think this data is going to help you to create some capabilities like this?
No.
Right? I think that is the challenge actually. Actually, what we require: soil type, month, what kind of crop, what is the output, how much water used, etc. Information helps us to figure out some application, right? But the data what they give is like this. Right? I think that is the challenge which you are going to have it. That's why now it is very important to educate the vendors also. Right? Simply what they think is whatever the CSV files I am having, I'll dump it and you come out with the AI model for me, right? I think you will face it when you face the customers. Yeah. Okay. Right now, data. I think this is some of the terms what we use, right? I hope. I think these are called as inputs are called as some names we use, right? Features, right? I hope. And output is called as response or target variable These are the
Label.
general target variable. Right? So features generally we call as, right? The model, that is algorithm, right? Objective function, how good already we discussed. Learning algorithm. So what kind of maybe these are all normal things. I think this is already what we discussed. So we have to train the model and we have to test it. Now, even though I think now by this time you already target. No, target is not a feature. I think Taresh. Target is not a feature. Inputs are features. Or in a mathematical sense, all independent variables are features and dependent variables or output is a target variable or response variable. Okay. Okay, I think learning problems same as supervised, unsupervised. The same discussion here also, reinforcement learning. I hope I'm just going to next slide, knowing that you are already aware of these two particularly. Reinforcement, we are not actually. This is a separate discussion. Any point to be added? Anything that you want from the supervised and unsupervised? Supervised, then what we require? Label data, right? Right. How to differentiate classification and regression? What is the difference between these two things?
Numerical.
Qualitative
Output
and
is
quantitative data.
regression is we are trying to find a value in the from the given set, and classification is how do we classify two things like if it is a cat or dog, something like that.
Okay.
Based on that, right?
Is kind of a
Regression is
definite output, right?
predicting a value.
Show up reinforcement is a very
Classification will have a categorical output where the regression will have numerical output.
Yeah, I'll come to that. I'll very simple. Now I'll say a simple example like y equal to f of x, right? And or if you want, I'll add more x1, x2, x3, so on. Right? This is right. I think this is labeled data only, right? Labeled data and supervisor learning. Now I'll take the example as house price prediction or policy prediction, like bank policy bazaar, they do, right? We give all the information entered. Then what is the output expected? What is Y expected in this case?
Price.
Price.
That means
Price.
target.
Is there any restriction on it? Depending on the value that we give, we get like maybe it is a 70
It's a real
lakhs,
number.
1 CR, 1.2 CR, like this, right?
Continuous.
Now, other case. Now we'll go to doctor. We'll go to doctor. Doctor is F. We'll give all the information X1, X2, X3, X4 are the inputs, right? Inputs we give it to doctor, right? And what is that we expect from the doctor?
Either we have
General
yes or no.
response.
Addition. Either we have yes or no.
So here it can be any number. Here it is only this, right? I think this is regression, right? I hope.
Yes.
And this is classification. This is the basic. You need not categorical, or generally you won't get categorical variable out of it, Shoaib. Number only, no? So output can be any number, that is regression. Output is only discrete, what we call as discrete. Here generally we take only 2 because binary, but it can be more also, but discrete.
Or
Discrete.
categorized.
Discrete is a simple time.
Okay.
Suppose a
Yeah.
feedback, so you'll have maybe 5 columns, 5 responses, then 5 classes, right? I think this is the difference between classification and regression. Then what about this unsupervised learning or clustering? Or actually, some people call this as a lazy learning.
We are trying to group same data, like all the class 1 students or all the class 6 students or like something like that. We are trying to do in unsupervised learning.
This is
So
actually, we call it a teacher learning. Actually, everything we'll try to understand data, everything, and we're ready. Training and testing, we're ready for a new case, right? Whereas lazy learning is not like this. Maybe in a lighter note, I'll give an example, not to offend anyone. If you take legal, that is lawyer. So how to identify? I think movies only, we never saw the people, right? In movies, how we identify lawyer?
Black coat.
Black coat.
Black coat and also books, right? I think lots of books you will see, right?
Yeah.
Books means not academic books actually. They're all judgments,
Legal,
right?
yeah, judgment
Judgments.
and
Judgments by various courts at various places. All those things I think you can see, right? Do you think that the lawyer has gone through all the books and ready for the client?
No.
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 No, right?
No.
So what it do when the client comes, then he will take the information and I will try to identify it, right?
Yes.
Right.
That is a lazy learning starts when the new instance comes. That is lazy learning. That is unsupervised learning. That is actually clustering. So here there is nothing specific, right? Here in this case, the systematic way of understanding the data, everything and ready with the algorithm, right? Now in this clustering, I'll give an example. Clustering, what does it mean? Now, you hired or you I think acquired a company with the head count of 1,000. Right? 1,000. Now, how you go for the organization structure? You had 1,000, all 1,000 are same for you, right?
Yes.
How you now, it depends on you, right? So I want to go like this. One is tech, non-tech. I'll decide first, right? Then I'll try to figure out of these 10,000, how many people are who falls under tech vertical and non-tech vertical. Or somebody is other person don't want to go with it, he wants to go with other structure, right? Right? He defines the rule or the structure. Then I will try to figure out, push this into the cluster. Clustering is nothing but groups, forming groups. Now, if I think regular example is your marks, grades, what we get, A grade, A minus grade, B minus, like this, right? We define it. The students who get this from marks from this to this falls under A, B. For one course, faculty defines one, sorry, one cutoff. For other, they define their cutoff, right? There is nothing specific and nothing specific rule. That kind of working with data falls under clustering. Clustering is nothing but forming the groups. I hope it is clear, right?
So, sir, after feeding the data, the groups will be created automatically, or we have
No,
to
you have to
step
define.
right?
No, you have to define. No,
Okay.
because I don't know what you are looking for, right? The organized structure, you want to have only two verticals, tech and non-tech. But I want to divide into business units. Customer wise, I want to do it.
Oh, sure. Understood.
Depends, right? That is where you have to define it.
Yeah, understood. Thanks.
The first example, I think maybe to understand is those who suppose if you are using Google Photos for first time. Google Photos for first time, it asks us, right? It asks us, it asks for the details, how you want me to group the photos. If you define it, do accordingly. Okay.
Sure.
And somebody is telling reinforcement learning is not so important. Yes, it is very important. Your driverless car and agentic AI, all those things take some knowledge or cue from this. Actually, reinforcement learning is equally or more important. Okay.
Sir, in unsupervised learning, still we are providing labels, so it's kind of feeding to the system.
No,
It's
unsupervised, we won't give labels.
like cluster names, which like take, non-take. We are giving the data, but we are telling like it should be in the take or non-take, like that.
Yeah, you have to, here, just for example, I take, then you have to give some rule. Then it will push each data into which cluster it belongs to. This is a generic idea I'm doing. Otherwise,
Yeah.
distributions, probability, we have to go for it.
One of the lecture I understood like we have to give the data and he will make it the cluster, and that cluster you can be give later naming as per seeing the
No,
cluster data.
name, nothing. Just that is a generic example I gave. Suppose if you see this. Now I want to group them. How can I group?
By finding some identification in those.
No, I want two groups only.
Okay.
Then I will try to figure out like this, right? I want three groups. I hope you understood, right? So first I have to define, I want to two groups. I define how I want to have these two groups, three groups or five groups. It depends on your requirement, right? So in this case, maybe other cases, I want to make this as a group, this as a group, this as a group, four groups, right? That is the idea behind. Okay. Then, so once we figure out this, whenever a new customer comes or new data comes, it will check whether this new data goes into this cluster or this cluster or this cluster, this cluster. Okay. So don't worry about it. Actually, this cluster is nothing but maybe yesterday I mentioned. If you see this, right? What are those?
Programs.
Normal distribution.
Bell curve, Gaussian.
No.
Bell curve.
Your Neelanchal Hills.
Oh, okay.
Any name that you can give? Neelanchalara or Himalayan ranges. It looks like this only, right? These are cluster. This is a cluster.
Cluster-wise distribution.
Then that is where academic learnings come to probably. Otherwise, if you say this is a cluster, this is a cluster, this is a cluster, this is a cluster. Okay,
But they are the same features. That's why they are in same cluster. Himalayan hills, they are high, have snow covered.
And no, there also will have no. These are all having similar properties. Therefore,
Correct.
this is one cluster. This is one cluster. This is all cluster of. Actually, in our sense, we call them a Gaussian clusters. It's a mixture of clusters. Okay, I think supervisor already we had a discussion, regression, classification, binary, recommended system, sequence, all are, I think, right. Okay, yeah. Now, what is the summary of today's? Generally, one minute.
I just saw multi-level.
I'll come to that actually. Multi-class and multi-label. Labels, you know, right? We'll have the discussion. I'll make it. Now, if we summarize what is the essence of, generally I'll explain. Generally, I'll summarize for after every 1 hour, I'll summarize the discussions. Now, today, what is the take? One is ML versus DL.
DL.
That is, I think, overall some understanding between ML, what in what case, when we need to go for ML, when we need to go for DL. And second, what is that we are going to discuss as a part of discourse under DL, right? So particularly, you need to be familiar in terms of at least names. You can, if you are new to this, tomorrow if someone is sitting discussing about something like this, then you can join the discussion and use these terms at least. Be a part of the flow. Right? Something like this, right? Now you should be confident in joining the discussion with other colleagues who are feeling that they are updated versions. Right? Now tomorrow onwards, you can say that no, why not CNN, why not RNN, LSTM, etc. kind of thing, right? And CNN particularly we use for in general for images, and RNN, LSTM these for sequential data. Like a machine translation, particularly stock market. You can see those who are following algo trading kind of thing. If you have a deep dive into algo trading, many of the guys had LSTM as algorithm used in it. Right? And transformers, now you can say that now what is the technology or the architecture behind ChatGPT is our transformer architecture. Right? Okay. Yeah. And we try to understand data, what labeled data, unlabeled data. And along with this, it comes as supervised learning and unsupervised learning. Right? And more clearly, when we take labeled data, sorry, is calling. Just a minute. Just 1 minute time, please. So label data, then immediately what are the approaches? One is regression and other is classification, right? So what is the basic understanding or difference between this regression and classification? Any? So here the output can be any value, right? That is a continuous value or variable we call as. Whereas classification, what is expected as an output is a discrete value.
Yes, no.
Yes, no, or 1, 2, 3, some restricted. But here it can be any number, no restriction on it, right? That is what. And particularly when we talk about classification, that is where binary and multi-class, right? I hope it is clear. What is binary? What is multi-class, right? Just number of classes. Like example, having fever or not, yes or no is binary. What kind of fever falls under multi-class? Whether the given image is a cat or not is binary. Whether the given image is a cat, dog, or elephant, etc., is a multi-class. I hope. Then I think our friend asked, I think, what is that one? Multi-level? What is it? I think multi-level, right?
Yes.
So what is this multi-level, right? So multi-level, suppose here generally when an image is given. In classification, what is that we expect as an output? Image is given. What is that we expect as an output? If it is a binary, it should tell us. If it is a multi, it should give us whether is it a cat or whatever it is. Only one expected, right? So multi-level means if we give image, it gives the output saying that this is having cat as well as dog. Okay, yeah, that is fine. So particularly there is I think somewhere tagging if you take, I think. So where the same news article is tagged, suppose if an article comes, the same article is tagged to sports column, same article is tagged to politics, same article is tagged to, that is a multi-label. Okay. Right, I think we can close it. Yeah, thank you. I think we got some, at least some
So one
inputs.
question.
The next
One
session,
question on.
1 minute. Next session actually where we start, this is just a basic discussion. In the next session, we start the actual neural net architecture and related discussion. Next session, we'll start with neuron, why this neuron, how this neuron architecture looks like, then etc. etc. Okay, yeah, thank you. So as I mentioned, maybe Wednesday, by Wednesday, you can see the next session PPT. Better you go through it so that we can have more questions and more doubts. Yeah, thank you. Thank you. I hope it helped you something, at least to gain some knowledge. Yeah.
Sir,
Thank you, sir.
I have
Thank
one
you.
question, sir.
Yeah, now I am open. Anybody ask any question?
Yeah.
Yeah.
So this is Vinod here.
Yeah, Vinod, please.
So right
Yes, yes.
now in our organization, we have a knowledge base.
Okay.
So, and the knowledge base is on a website.
Okay.
And what, at least my team is thinking, we want to convert that in that knowledge base into a chatbot. So something similar to ChatGPT, which does more than answering questions. So do we use transformers to actually build that? Or is it an LLM? I don't know what the approach that needs
Actually,
to
transformer is an architecture which is the base for many of the things. LLM, yes, base. ChatGPT, transformer is the base. RAG, yes, as mentioned. Transformer is the base for many of these things. Now it depends on that knowledge that you are having. Right? I think based on that, we can think of maybe, as I mentioned by our friend, RAG is one kind of application which we can look.
Okay, Raggy. Okay.
Right.
Okay.
Sir,
Yeah.
Sir, what is this transformer? So if you just can give a brief little bit.
What
was my question. What is this transformer? Transformer is you mentioned CNN, RNN, LSTM, then
Transform is
transformation.
also another architecture. Another architecture. But it's a wonderful architecture. That is where they actually the exponentially the revolution happened because of the transformer architecture. And even the transformer architecture is not a new thing actually. Almost similar philosophy like this. The attention all you need paper by Google research changed everything. They added this attention mechanism to existing architectures. That is where the transformers and all those things revolutionized. And it is not the Google team did it. Someone else used the Google research paper. Yes, I think you can say. Many of the LLMs or the NLP applications based on the transformer architecture.
Okay,
Sir,
thank you.
in one of the slides, it was written under unsupervised. Generate synthetic data. For this, we use GAN. So what does it mean?
Sometimes what happens, no, you are not having data, right?
Okay.
Sufficient data. There are ways to generate data. In ML context, there are some methods to generate data. That is where I think GAN we use to generate synthetic data.
And why would we use it? Like any example? We want to use something, but we don't have the data for it.
Data, sufficient data, like restricted data, very less data kind of thing. That is where we can.
Okay.
Yeah, that is a possibility. In case of images, it may not be a problem. But in case of some applications, you may not have, I think particularly the restricted domains, if you say. Suppose if you want to build an application related to pharma industry, I think no pharma industry is ready to share their knowledge, right? No one shares their data with anybody, right? Then how to build? How to build?
Okay, so is this a fake data, dummy data, or
synthetic data, what we call as?
Okay.
Synthetic data. So one of the approaches is using GAN.
And what does it mean actually? GAN, like abbreviation of what?
Adversarial networks, generative adversarial networks. Yeah.
Okay. Okay. Thank you.
Okay. Thank you.
Hi, sir. In the unsupervised learning, right? Like along with the multi-label, there is one more thing called multi-class, right? What does that mean?
Multi-class is what I think when you if it is with two classes, then binary. More than two is a multi. Like when you go to doctor, what kind of fever he list out? Like it may be malaria, typhoid, 4-5 fevers, right? Then is a data with 5 classes. That is multi-class.
Sure.
So can we say different features, different features, and then about multi-class when we say different features together? Like for an example, the cat example. So cat is sleeping. So sleeping, standing, and these are different features, right? Cat, dog, these are different features. Is it the right way to understand? Or?
No. Actually, that is image. Now, with image, what is that you are looking for, right? That is important. Now, I had images of cats, right? So I want an algorithm which whenever I give an image, it should tell, is it a cat or not? But what I mentioned is here, I want to know the description of feature means description, right? In one image, cat is in some color and is doing something yoga. Like that is a difficult thing for us to identify it, right? The other one is if you want to have
ये बोल रहा है रिमोट में सुन के रिमोट वो टीवी जवाब देती है वो कैसे होता है क्या करना होता है कैसे
If you're
समझाएं
not
उसको
speaking, you can go on mute.
The other one is what I am saying is suppose image is given, you want to have the description of the image. That is a different application, right? Now you might have seen in even when you watch OTT platform, you will get the description, right? When the scene is going, you will get the description. That is a different application, right? That is a different application. It's not a classification, right? Yeah.
Okay. Got it.
That is
Just
a
a
more
quick,
popular.
Sure. Yeah. Okay. Just one more thing, sir. This presentation and annotated version you will be uploading in Takshila or Teams, right? Teams. Okay. Okay.
Yeah.
Thank you.
Okay. Thank you. Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you for making my day with your
Thank you, sir.
sharing of knowledge. Nice, nice. I hope that it will continue the same. Yeah.
Thank you.